Similar figures and scale factors. These first questions have to do with really the definition of what are similar figures or congruent figures. So which of the following is true about similar figures? It says similar figures have congruent corresponding angles. That means their corresponding or matching angles are the same. And that is a true statement. So right away, letter A is true. Similar shapes, the angles match up and are the same. We'll go through the next part here too. Similar figures have the same size but different shapes. Okay, that's really not making any sense at all. They would not be the same size, nor could they be different shapes. Like a triangle is never similar to a rectangle. So no, just rule that out. C, corresponding angles, the matching angles, are proportional, not congruent. That is true about their side lengths. Their side lengths are proportional and not the same. That's why similar figures are either blown up or shrunk down by the use of that scale factor, what you multiply or divide by to make it similar. And then lastly, similar figures have the same size and shape. Nope, that would be congruent. Congruent is when they're exactly the same. So letter A was true. Their matching angles are the same. This next example, the two rectangles shown above are similar and congruent. Okay, that could never happen. They're either going to be similar or congruent or neither. Well, W stayed W, but L turned into 3 times the length. So the width stayed the same, but the length is multiplied by 3. That is not possible for similar or congruent. Congruent means they're exactly the same, which they're not. And they're not similar either, so the answer is D. They're neither, because this was multiplied by 3, so the width would also have to be multiplied by 3. So they don't have the same proportion for the side lengths, so it's neither. This is a classic example. Here's two rectangles. They're similar. If A is 10 and B is 15 and C is 20, well, what's the length of letter D? If you put these 3 labels in, the side lengths, the short sides go together, so 10 turns into 20. It's doubled. So 15, double it, you get 30. The answer is A. The big rectangle is twice the size, the side lengths of the little rectangle, so it's doubled to get 30. And you could set up and solve a proportion as well. If you wanted to, you could say, well, the short side goes to the long side, and then the short side goes to the long side, and 20 times 15, 300 divided by 10 is also 30. Our last example here is another kind of 2 similar triangles. We're given a word problem where Pete is standing 4 feet away from a mirror on the ground. There's our 4. Pete is 4 feet tall. There's another 4 feet tall. And I can see the top of the tree from where he's standing. The mirror is 16 feet away from the base of the tree, 16. The 2 triangles formed in the picture above are similar. How tall is the tree? So we can match this up. Well, this one worked out pretty nice because the 4 stays a 4, so the 16 would stay a 16. The answer is D, 16, because the height of Pete to the distance from the mirror is the same as the height of the tree to the distance of the mirror. 16 times 4 divided by 4 would be 16, because that would make these 2 fractions equal. So D, 16.